Hey everyone, you know there are some things we do every single day, dozens of times, without ever thinking about what's really going on. Well, today we're going to pull back the curtain on one of them, updating a calendar invite. It seems so simple, but you're about to see the incredible magic behind that one little click. I mean, of course you have, right? You just open your calendar, you find the meeting, change the time from, say, 2 p.m. to 3 p.m., you hit save, and that's it. Boom! Instantaneously, everyone gets the update. But what actually just happened in that split second? Because what feels like a simple, instantaneous action to you and me, it's actually kicking off this incredible, high-speed relay race in the cloud. Behind the scenes, a whole team of specialized digital services are sprinting, passing the baton from one to the next, all to make sure your update is processed perfectly. So, who are the runners in this digital relay? Well, let's meet them. This is the cloud team, and each member has a very specific and very crucial job to do. First up, you've got Amazon SQS. The best way to think about SQS is like the velvet rope at an exclusive club. It's the digital bouncer, the waiting line. As soon as you send your update, SQS grabs it and puts it into this perfectly orderly queue, making sure that nothing gets lost or trampled, even if thousands of people are all sending updates at the very same time. So once your request is in line, who grabs it? That would be AWS Lambda. This is our specialist worker. Now, Lambda doesn't just sit around twiddling its thumbs. It's a super efficient piece of code that literally springs into action only when SQS says, hey, there's a job to do. It's like a master craftsman who shows up, does one perfect task, and then disappears. And where does that Lambda worker get the event details it needs to update? It goes to Amazon DynamoDB, which is our hyper-organized digital filing cabinet. And trust me, this is not your grandpa's dusty old office cabinet. It's a ridiculously fast, high-performance database that can find and retrieve the exact event details our worker needs in a fraction of a second. And then finally, after the update is officially made, Amazon SNS takes the stage. Think of SNS as the digital town crier. Its one and only job is to shout the news from the virtual rooftops, broadcasting that final update to every single person on the invite, making absolutely sure that everyone's calendar is perfectly in sync. All right, so now that we've met the team, the bouncer, the specialist, the filing cabinet, and the town crier, let's see them all in action. We're going to follow just one tiny update request on its journey through this whole system. So let's just imagine for a second that our request is this little packet of data. It's just been created by your click, and it's about to go on this epic 5-step journey through the cloud. Let's trace its path. Okay, you ready? Here's the play-by-play. It all starts the moment our request lands in that SQS waiting line. That's the trigger. Instantly, our Lambda worker wakes up, grabs the request, and zips over to the DynamoDB filing cabinet to pull the original event info. Then it does a quick comparison, what's new versus what's old. If it sees a change, it updates the record right there in DynamoDB. With the change locked in, Lambda gives the signal to our SNS town crier to go broadcast the news to everyone. And then, finally, and this is so important, the original request is deleted from the SQS queue. Its job is done, it's cleaned up, and we're ready for the next one. And you know, what's so cool is that you can actually see this logic in the code itself. You'll find functions with names like getEventUID from or updateEvent. They're not cryptic, they literally describe their exact job. Sends notification of updated? Well, you can guess what that does. It's this kind of clear, focused design that makes the whole system so incredibly reliable. But let's be real, things don't always go perfectly, right? Any good system has to have a plan for success, but also a plan for failure. So let's take a look at how this setup handles any bumps in the road. So there are really two main paths here. Most of the time, you're on the success path. Everything we just talked about happens flawlessly, and the message gets deleted. All good. But what if there's an issue? Maybe the request is malformed, or the database has a hiccup. That's the error path. And this is where the system is really smart. It doesn't just crash. It simply logs the error so a developer can look at it later. And then it just skips that broken message and moves right on to the next one in line. This is huge because it means one bad request can't bring the entire system to a grinding halt. So you might be wondering, why go through all this trouble? Why build a system with all these moving parts? Well, it turns out this modern serverless way of doing things has some pretty massive advantages. Because when you boil it all down, this whole intricate, complex system, it all comes down to just one single thing. Your one click. That's it. That's the power of this kind of architecture.
It's incredibly efficient because those services only spin up and you only pay for them when there's actually change to be made. It's super reliable because that SQS queue guarantees your update will never get lost, even if your entire company decides to reschedule meetings at the exact same moment. And that makes it unbelievably scalable. The system honestly doesn't care if it's handling one update or 1 million updates. It just works.
And this line from the source material it really nails it. The whole point isn't just to update an event, it's to automate it, yes, but also to keep the data perfectly accurate and to make sure everyone involved knows exactly what's going on. That right there is the definition of a great system. So I'll leave you with this thought. This immense complexity is hiding behind one of the simplest actions you take every day. So the next time you click send or post or buy now, maybe just take a half second to wonder, what incredible digital relay race did you just kick off? What hidden world of technology just sprang to life because of your one simple click?